Okay, this video is going to help you see how to do the topics of 10.2, 10.3, recognizing what kind of problem based on the words that we give you. So here we go. First thing I've been showing them is for any graph or any word problem to be exponential, one of these graphs that curves up steeply like that, you need a percent. So anytime you see a percent symbol, that percent symbol means that that word problem is exponential. So I would say 4 is exponential because of that 12%. And then down here, 6 is exponential. As soon as I see that percent, I know it's exponential. So again, look for that percent. If it's got a percent, it's going to be exponential. It's going to grow steeply like that. All right, the other ones are linear. Linear is a straight line kind of situation, straight line. So if I look at a rent problem, a rent where I'm adding the same amount each month, adding 500 each month, that means this makes this linear. So number one, anytime I see just paying that same rent each month, for sure linear. All right, next couple, if I look at this next one here, I need to do an actual, a little bit of math. I got 1 hour, hiked 5 miles. So again, that's 5 is my first number. And then if I look 2, I have 8. 8 is my second number. And then if I look at 3, I have 12. If those numbers are going up by the same amount each time, it's linear. If they're not, it's going to be neither linear or exponential because there's no percent. So if I see from 5 to 8 going up by 3, but then from 8 to 12 going up by a different number, going up by 4, because of that, that makes this not linear. No, not linear. That makes this neither, because a graph like that is not going to be straight. It's going to be kind of straight, and then it's going to get like this or something, or maybe go like this and then get steeper. It's not super straight. It's neither. If this would have been plus 3, then this would have went into the linear column if that was going up by the same amount. But because that's not, I put that in the neither category. All right, next one. Adding by 1/4 of an inch per week. Again, I'm adding just 1/4 of an inch, 1/4 of an inch each week. That makes this for sure linear. There's no percent in there. And then my next one, I need to do a little bit of math. Here's the last math here. So if I take 50 and 2, I divide that to find the rate. $50 divided by 2 hours gives me $25 for every 1 hour. That's its rate of change. That's its M number. That's the number that goes in front of X. That number goes right here in front of X. If I look at the other one, if I look at 3 and 90 and divide those, $90 in that 3-hour stretch gives me $30 per every 1 hour. Because these two are not the same, this one is not going to be linear. I'm going to put this in the neither category right here because it's neither. If this was going up by the same, if I would have had the same amount, if I would have had both divide and give me $25 per 1 hour, I would have then put that in the linear category because, again, going up by the same. But because this problem did not go up by the same amount, I put that in the neither category. And now I need you to know how to write basic equations. So here we go. Try to write. For rent, I'm going to use f of x. So f of x right there, the number that goes in front of x is always the rent. What you're paying, what's changing each time, that number goes in front of x. The number that you're adding for the deposit, that is a one-time adding fee. So that gives me an equation 500x plus 2,000. My next one here, because this is neither, going to be no equation. All right, this last one here, adding 1/4 of an inch, I'm going to say the first one is growing at 0. There's no grass at the beginning. So then it goes up by 1/4. And then my next, whoops, let's change that, sorry. So if I go 1, it goes to 1/4. And if I go 2, it goes to 2/4. If I go 3, it goes to 3/4 of an inch. It's adding by 1/4 each time. My number above the 0 term is 0. So this equation, I'm going to write f of x equals that 1/4 x plus a 0. Sorry, it kind of bled into the other problem right there. That is the equation for that grass one. All right, percent. Here we go. I got percent starting at 50,000. That's going to be the 0 term. So that number right away is my 0 term. And then I'm decreasing. So that means I'm going down. So if I take 1 minus 0.12, that gives me 0.88. That's what I'm going to be timesing each time by 0.88, timesing by 0.88. If I take that 0.88 and times it by 50,000 using my calculator, sorry for the delay, it goes down by a little bit. It goes down to 44,000. And if I times that by 0.88, it goes down to 38720. All right, my equation for this one is that 50,000x in parentheses that 0.88 raised to that x power. Again, knowing how to write explicit geometrics. That's for this guy right here. All right, next for this one, there's no equation I could write, either geometric nor linear. All right, last one. Here we go. I got 3%. So starting at 0, 30,000. That's my 0 term. I know I'm timesing right here, increasing. So I'm taking 1 and I'm adding to 0.03. That gives me 1.03. So that's what I know I'm timesing by. I don't even need to find my other numbers, but I'll write a couple here just to show you what's going on. So 30,000 times 1.03 goes up to 30900, and then that times 1.03 goes up to 31827. All I need for equation I have, so here I go. Here's the equation. The equation is 30,000 in parentheses that 1.03. Close that parenthesis and make sure you get full credit and put that x in the exponent spot. That is my exponential. That's geometric right there. All right, let's go on to a couple more examples here just to help people who are needing to understand. So here we go. Next one, look for percents. Any percents automatically go in the spot where you have exponential. So I got 2 exponential. I got 6 exponential because of those percents. Now look for the other ones. Let's see if I have any linear ones, just adding without any percents, just adding every time without any percents, or subtracting maybe. So if I look at this guy going up by 30 every time, going up by 30 each year, so that means this one for sure is linear. If I look at this next one here, rent, again rent, just adding that 5,000 each month, adding, let's do that in blue, so my adding numbers are always blue, going up by 500 each month. Again, there's no percent symbol in there. Going up by the same, that makes this linear. If I look at my next ones here, a little bit of math. If I divide 40 and 2, that gives me the rate per hour. $40 in 2 hours gives me $20 per 1 hour. Do the other one. If it's the same, then it's linear. 90 divided by 3 gives me $30 per 1 hour. Because these are not the same, I put this one in the neither category. If these would have been the same, if I would have had both be equal, like both would have been 20, then I would have put this guy all the way into the linear column, but it's not. So here I go. So for this one goes in the neither category. All right, moving on. Next one. 1 going up to 8. My second number, 14. Third number, 20. Because these are going up by 6, looks like they're going up by that same 6. This one is a linear situation. Linear, going up by the same amount. All right, and then writing my equations. Here it goes. Write a couple. Looking at this guy. 0. The 0 term is that 30,000. Oops, let's do that in green. The first term, I'm adding 30 to it. This is linear. This is linear. So that gives me 3, 0, 0, 3, 0. And then my next one, I'm adding another 30 to that. And that gives me 3, 0, 0, 6, 0. So for my equation, I have what I need. This is linear. So there's no exponents. I take that 30 and put that 30 in front of x. I add it to that 30,000. It's a one-time deal, that 30,000. That is that linear. All right, let's do the next one. Got 0, 0. First one, timesing by a quarter an inch. That's kind of tricky. That is 0.25%. That means I'm timesing this twice to the right. That's 0.0025. This is a growing. So I'm timesing. Let's see, for this one here, I should have gave you a first value because I don't really want you timesing by 0. So we'll just cross that one out for you because I kind of messed that one up. All right, here you go. Next one. Looking at this guy here, 500 is the 0 term. I'm sorry, 2,000. Going up by that 500 each month. So this gives me 2,500. This gives me 3,000. That is linear. So here's my equation. Equals that 500 in front of x plus that green 2,000. All right, let's do another couple here. Looking at this guy. This guy, 1, 2, 3. I have to go back to the 0 term here. I got to subtract 6 from this 8 right here. Gives me 2. So for this one's equation, I have f of x equals that 6 front of x plus that green 2. All right, and then it looks like I do have an exponential. I gave you a 0 term. So here we go. This one's 0. I'm going up to 50,000. First term going up by 0.5%. That's 0.5. That move to the right is 0.005. I'm subtracting that away from 1. So using my calculator to subtract 1 minus 0.005 using the calculator gives me 0.995. So I'm timesing by 0.995. And I'm not going to do that. I'm just going to write the equation. So here you go. The equation. I have that 0 term, 50,000. In parentheses, that 0.995 raised to the x power. That's going down by a tiny percent. All right, that is exponential. All right, I'm going to just do one more set. Here we go. First thing you need to do is look for any percents. Look for percents. Look for percents. Anything with a percent exponential. Look for percents. I got percents right there. I got another percent right there. I keep looking for percent. Oh man, this one has 3 percents. I got 3 geometric, 3 exponential, just because I see that they have a percent symbol in there. There we go. Super easy. All right, my next one's looking at 1/4 of an inch per week, adding 1/4, adding 1/4. That same adding 1/4 makes this for sure linear. All right, babysitter one, where I got to do a little bit of math. Here I go, taking that 2 and divide it into that 50 to find the rate and seeing if the rate is the same. Straight line, $25 per 1 hour. And then if I divide 3 and 75, that gives me $25 per 1 hour. Since they're the same, I both have $25 per hour. Hopefully that writing's not too sloppy. That makes this linear because they're the same. All right, next one. This one. At 1 hour, first number, 5. Second number, 8. Third number, 12. Because this looks like they're not going up by the same. This one is different right here. Not the same. That makes this one not linear. This one's not linear. Don't put it in the linear section. That makes this one for sure non-linear. And then one last little gasp at writing equations. Here I go. 30%. That is adding by 0.3. So this is 30,000. Let's do that in green to keep my y-intercept solid. First term I'm going to be timesing by 1.3. That's what 0.3 is added to 1. That gives me 1.3. That's my R term right there. So if my equation, before I even have to find how much I have after the first term, is that 1.3 in parentheses to the x power. Of course, if I wanted to really times that, 30,000 times 1.3 goes up to 39,000. You can see going up a lot. And then if I times that by another 1.3, goes up to 50,000. So you can see going up. That's why you get this curvy look to these exponentials with percents in them. All right, here we go. This one, 1/4 of an inch. I'm going up, starting at 0, 0, adding. So I'm going up by 1/4 of an inch. Whoops, let's just do that in black. Adding by 1/4 of an inch makes this 2/4, 3/4. Adding by 1/4. Here is my 0 term. That equation, f of x, equals that 1/4. Remember, this isn't a timesing one. That is in front of x normal, plus that 0 if you really want to write it. All right, here we go. Almost to 0. 2,000. 1. I'm timing that 2,000 by an extra 5%. So that is 1.05 I'm timing right there. 1.05. 2,000 is my y-intercept. Let's clean that up a little bit. So my y-intercept is 2,000. My first term, I'm taking that 2,000 and timesing by 1.05. So you can see his rent is not very much. It's going up 2,100. So you can see his bank account is saying that every month you're going up by about 100. Just over 100, because the second term just over 100. So here we go. My equation is that green 2,000 times in parentheses that 1.05. Close that parenthesis. Put that x right there. Exponential. All right. I'm going to do one more. Here we go. 0, 50,000. Going up by, going down. So that's timesing 1, take away 0.08. Gives me, I think, 0.92. So that's my timesing number. If I'm going to write this equation, I got 50,000 in parentheses that 0.92. Close that parenthesis to the x power. All right, and then looking at this one here, I got the same slope. I'm not quite sure what their amount of money they had in the beginning, so we'll say maybe they had 0, so I think their equation, let's just say f of x is that 25. That is my rate of change, x. And I won't put number there because, again, plus 0, they're starting at $0. That is their 0 term. So just plain old 25x, that rate of change goes in front of x. Good luck.